In this video, I'd like to talk about how to graph quadratics in vertex form. So before we try and actually start graphing this, we should ask ourselves, what is vertex form? And vertex form, in its simplest way, can be just written as y is a times x minus h squared plus k. So it's this expression, this form of a quadratic where you have some binomial squared. You might have a number multiplied in front, and then you're adding or subtracting a constant at the end. And if you remember your shifting of functions, then you know that if you add or subtract on the outside, it shifts it up or down. So if you add, let's say 4 in this case, then it's going to shift the function up 4. And I should mention that we're comparing it to the parent function, y equals x squared, which is going to look something like this, probably a little bit cleaner looking, but you get the idea. And so adding on the outside shifts it up. If you subtract, it shifts it down. You're basically just taking your y values at any given point and adding 4 to them. Now, on the inside, the x values are a little bit trickier. It's always the opposite of what you'd expect. So even though we're adding 5 on the inside, we're actually going to shift it left 5 units. So that would bring it over here, and then with the plus 4 on the outside, that shifts it up 4. So you're looking at a vertex somewhere over here. But one way I think about the x values and why they shift to the left in this case instead of the right, it's always the opposite of that sign, is I like to ask myself which x value makes the expression 0. And in this case, it's minus 5, and that tells me to go left 5. So that's how I think about it. And when you look at this vertex form, the vertex is just going to be how much you shifted left and right and how much you shifted up and down. Because the vertex of the parent function is right here. It's just at the origin. So our vertex, it looks like we're shifting it up k units. So our y value is going to be at k, because remember this is starting at 0, 0. So we're adding k units to y. And then our x value, think about what x value makes this expression 0. And that would be a positive h. So even though we're subtracting, we're actually going to go to the right h units. So our vertex from this general form for the vertex is at h comma k. So whatever you're subtracting here, that's the positive x value of the vertex, and whatever you're adding or subtracting, that number will go for your y value of the vertex. So let's again look at this equation. Y equals minus 2 times x plus 5 squared plus 4. And so comparing it to our vertex form, you want to think how much did you go up and down and how much did you go left and right compared to this parent function. And so in this case, our vertex looks like minus 5 would make this equal to 0. So our vertex compared to this parent function, which was at the origin, is shifted left 5 units. And then whatever you add or subtract on the outside is how much you shift your y values. So the y values are straightforward. If you're adding, you go up. But with the x values, it's the opposite. If you're adding, you actually go to the left. If you're subtracting, you go to the right. So the y value of this vertex, we just shifted it up 4 units. So we can actually plot this point. And let me make a little bit of room. I'm going to get rid of our parent function here. So now that we have more room, let's first plot our vertex. I'll do it in this pink color here. So at minus 5, so left 5, 1, 2, 3, 4, 5, and then up 4, 1, 2, 3, 4. So we're looking at this point right here. So this is our vertex. And at this point, what I would recommend, since this is an x value of minus 5, just choose an x value either on the left or the right, because at your vertex, it's going to be symmetric on either side. So it's either going to go down like that, or it's going to go up like that. But regardless, if you find the x value, say right here, then the x value of minus 6 would have the exact same y value as minus 4, because there's symmetry on either side. And the question becomes, which way does it open, up or down? And you can usually tell this by just looking at this a value. If a is a negative number, all the y values become negative below the vertex. If a is a negative number, then our graph is going to open downward just like this. Now, granted, we don't know exactly how it's going to open yet. We need to figure out some more points, but we do expect it to open downward. And so what I'm going to do, and this is the general strategy once you find the vertex, I'm just going to pick one of these points and plug it into my function. Once I find that second point, then I can just use this axis of symmetry to graph a point on the exact opposite side. So let's do -4, though you can do -6. Honestly, you can choose whatever value you want and then use symmetry to find the other one. So like let's say you did -1, which is 4 to the right of that. Then you would have to plot the point 4 to the left of that at -9. And -1 and -9, when you plug them in here, they're going to give you the same y values. So you'll still be able to use symmetry, but you don't want to pick something that's, say, 2 points away and then plot it only 1 point on the other side. That will not give you the right answer. So we're going to plug in -4 into our function here and just see what we get for the y value. So y is -2 times -4 plus 5 squared plus 4. So this is just 1, and 1 squared is 1. So this just becomes -2 times 1, or simply -2, and then you have plus 4. So this simplifies to +2. So basically, when x is -4, then y is +2. And so we'll plot that. So this is our -4 value, and we'll go up to +2 right there. And we'll use symmetry now. So -4 had a y value of 2, but that would be true also for -6. That would also have a y value of 2. And if you plug that in, you'd get -6 plus 5, which is -1, and -1 squared is +1. So you'd end up with the exact same equation in the end. Now, when you actually graph these on the exercises with the Khan Academy, when you're not doing it by hand, the interactive grapher will help you fill this in once you get a couple points. So you won't have to do any more than this. Now, if you want to be really precise, you can even figure out where it crosses this x-axis. Though, like I said, with the interactive grapher, you don't need any more than this. So we could just kind of fill it in at this point. We're just doing a rough sketch freehand. But like I said, you can also figure out where these intercepts are, because this is when y equals 0. So you can just set y equal to 0 and then solve for x. And you can figure out these exact values. But in all likelihood, they're probably going to be some maybe irrational numbers.